Hey everybody, today we're going to review for the activities or the quiz on logarithms over activity 4 and 5. The non-calculator portion is this whole first page, and there are 7 questions on the non-calculator part, and 16 overall. There are 3 like these first 7, and they're kind of a little bit of everything. It all involves, all of them involve using the log base of the answer. So all of them require that you know this. Log, here's the location of the base. The answer is here, and of course it's set equal to the power because that's how logarithms work. So 2 to the what power is 32. You can figure that out in your head. You can write it out. You can just 2 times 2 times 2 times 2. That is 2 times itself, 5 times. For number 2, we have 4 to what power is equal to 1 over 16. The goal is to make the bases match when you have 2 sides like this. So that's obviously a 4, and 16 can also be written as a 4 with 4 squared. Now to flip this fraction over, because you don't want the 4 in the bottom, you make the power negative. So 4 to the x is equal to 4 to the negative 2. Bases are gone, and x equals negative 2. Now for number 3, same idea. 25. Ooh, sorry about that. Not sure what's happening. 25 to what power is equal to 1 over 5? So 25 is really 5 squared, except you want to write it correctly. So we have 5 squared is equal to, and there's an x up there, and then of course this is really 5 to the first, but to bring it out of the basement there, you make it negative 1. So now we have 2x equals negative 1, and when you divide by 2, we get negative 1/2 for number 3. For number 4, 3 to what power is equal to 1? Anytime your answer is 1, the power is 0. And that's just something you'll have to know. Obviously, without the calculator, there's really no other way to check that. You just have to know it. Now, for number 5, we had one like this when we did the add 'em up game. And you have to start by dividing both sides by 3. I'm really sorry about this pen. Oop, not the 5. So here we get 1 equals log base x of 6. And then you swoop this out. X to the first is equal to 6. Well, x to the first is just another name for x. So clearly x there equals 6. I'm still trying to get my pen to work right. Let's try this. So now we're going to try number 6 here. X squared is equal to 25 because we swooped that out. What number squared is equal to 25? Well, 5 squared is equal to 25. So then x equals 5. Now for number 7, it looks crazy. It's really not too crazy though, honestly. Still trying to get my pencil to work. So this is 3 squared is 9. And then this is log base 9 of 4. When the bases match, everything's gone. So simply it's x equals 4. Now the next part. You'll have one like this where you have to put it back in logarithmic form. So we know what it goes log. Again, where's my pencil? Log, the base is the 5. The answer is 1 over 25, and it equals the power. So there's really nothing to do there. You're just rewriting it. There will be one problem, like 9 and 10, where you have to expand. So one problem like this. And so remember powers come out in front. Multiplying is really adding. So we have the natural log of x squared plus the natural log of y to the third. Then you bring the powers in front of each one individually. 2 natural log of x plus 3 natural log of y. For number 10, we have multiplying and dividing. So we'll have a plus and a minus sign. So we're going to have the log of A plus the log of B minus the log of D. There's not much else to do there. That one just went right in order. Because this would be the multiplying part, and then where we see the minus sign, that's division. Negative means it goes on the bottom because it's a negative exponent. Now to put this back together, I'm still trying to make this darker. It's just not working. All right, so this is a power, so now we're going to have log of a to the third minus log of b to the fifth. The goal is to write it with a single logarithm. That's what that says. So we're going to have the word log written one time. And this minus means it goes in the bottom. So a to the third's on the top and b to the fifth is on the bottom. For number 12, again, there'll be 1 like this. For number 12, the 1/3 power is really the cube root. So we're adding, so it's really multiplying. So we'll have the natural log of z, x to the 1/3, and y to the 1/3. Well, please don't leave it with the 1/3 power. Since these have the same power, which remember goes power over root, right? So that's how that works. So then we can leave the z out, and we'll have the cube root of x, y. Then also on the non-calculator part, you will have to solve one equation. So first thing you want to do is, if you don't have the log everywhere, you want to put it back together. So we put this side back together on the left. This is going to be log base 3. Adding is really multiplying of 3x equals 45. Now that it's all put back together, you swoop this out. That's how you get rid of the logarithm. Because if you have the logarithm, you want to get rid of it. If you don't have it, you want to get it in there. So I'm a little bit confused because of the way this is written. I think it's a mistake. So let's fix this. Let's figure out what we're doing here. My fault. It's not going to erase. All right, so awesome. You can't do that without a calculator. 3 to the 45th power. It seems a little bit like a lot. The answer, I think, is wrong on here, on the answer sheet. 3 to the third. Let's put it back together. Sorry, I'm going to go back to where we were. So this will be 3x equals 45. So we're really not going to be able to do this. 3 to the 45th power equals 3x. Without a calculator, I would not expect you to do that. So that's a bad example. So it won't be like that on the quiz. It'll be like this one on the quiz. First thing you need to do to both sides is divide. Right? Because don't put that back as a power because you're going the wrong way. You're making the problem back into a logarithm. We're trying to get rid of the logarithm. So now we have log base 2 of 3x equals 3. And then we do over here. So we have 2 to the third equals 3x. Divide both sides by 3. 2 to the third is 8. 8 divided by 3. We'll just leave it like that. It's simplified. No calculator, so you can't fix it anyway. Now, on the second page, there will be 5 problems like these. And just as you see at the top, the formulas will be just like that. There will be no separate formula sheet. They'll be right on the test, and there are 5 questions like this. And I just lost the black one, so maybe we'll do all this one in red. So for number 15, it says we have a population that's decreasing, and so this would be decay, exponential decay. And decay is subtract. So we started with 550 trout, It's 1 minus, make your percent a decimal, 0.013. And the time, of course, is from 2000 to 2019, so that's 19 years. Put that in the calculator, and you get 428.9. Well, 0.9 is really close, but it's not a whole trout, so we'll call it 428 trout. For number 16, just trying to figure out how to get the black one back. I can't find it. Oh well. Sorry. We have initial investment and compounded annually. If you would like to use the compounded interest formula, you can, but when n equals 1, it's not really going to do anything to the formula. You're not going to, dividing by 1 isn't changing anything, so we can just use the regular old formula of exponential growth. So 1 plus 0.03. The power is raised to 25 because that's how many years it is. Remember, this is money, so we want to go to 2 decimal places. So we'll have $37,688. Now make sure the question asks for the balance or the total amount of money, which it does, and not just how much interest there was. So this is the amount including the 18,000, which is exactly what they're looking for. For number 17, we did one like this with Margaret. And we have successive years. So it went from 15,000 in year 1, and then 15,525 in year 2. We don't have to go further than that. You could do the second year if you'd like, but I'm just going to use these two, as long as you make sure that you have years that go in a row. So they do go in a row, and we're just going to take the second year, 15,525, and divide that by the first year, 15,000. This will give you your growth factor, which is 1.035. So remember, what that represents is 1 plus r. So we really don't need the 1. We're going to take the 1 away and move the decimal point over twice. So this is 3.5%. Number 18, we're looking for the interest after we started with $25,000. So this is interest. It's also compounded daily. So you have to use the right formula here. This is 25,000, and then 1 plus 0.035. Daily is 365. The power 365 for 5 years. Now this is not the answer we'd like. From the calculator, you get $29,780.81. But the question would like to find the interest. So you got to take off the original amount and subtract that. So just the interest was $4,780.91. So please make sure you read the questions carefully. Oh, I got the black one back. All right. So determine the balance after 20 years. It's compounding continuously. Continuously is this one. So now we're going to have our initial amount, 25,000. And then this is going to be E. I don't know why I use parentheses. Parentheses are unnecessary. The 0.05 is your rate, and the time is 20 years. This is asking for the balance again, so we don't have to subtract. And it is going to be $67,957.05. Now on this last page, there will be 4 problems like this. 4 solving problems with your calculator. It is possible that you get no solution, so make sure you do check that. And so we want to put this together. Now, they do all have the log base 6, so you could get rid of them, but be careful with that because you want to make sure you do it correctly. Put the power back on all of this stuff. So this is really 4 squared. Then we're going to divide by 8 to the 1/3, and it equals x. So there's not much of an equation here. This is just arithmetic, which you can use your calculator for. 4 squared is 16. 8 to the 1/3 is 2, and 16 divided by 2 is 8. So no variables there. For 21, again, they both have log x, so you can get rid of that, but be careful because this is a power. Don't divide both sides because the logs are there. So now we have x to the 1/3 equals 8. Well, you would raise both of these to the third power. That's how we'd make that power 1. So that makes the power 1, so we get x equals 8 to the third, which is 512. Now, for number 22, the log isn't there, so probably we're going to want to put the log in. So if it's not there, you want it, and if you have it, you're trying to get rid of it. You can take the log of both sides, you can take the natural log of both sides, or you can take the log base 4 of both sides, because that's what's holding up your power. These are gone, and we just get x equals this amount. Now, if you don't have the key, that log base key, you're going to enter in the calculator log 100, close the parentheses, divided by log of 4. We're going to 4 decimal places, so we get 3.3219. For number 23, we can't do anything with this. There's no numbers to divide or anything, so we're going to start right away by taking the natural log of both sides. These decimals are tricky. Make sure you don't lose them. So these is gone. So now we just have the natural log of 60.3 equals 0.1 t. So we'll divide both sides by 0.1. When you put that into the calculator, the natural log is 60.3. Close the parentheses before you hit divided by 0.1, no matter what kind of calculator you have. We're going to 4 decimal places, so t is equal to 40.9933. Now for 24, because the 100's there, you can actually divide both sides by 100 first. And you should. Get that e all by itself. So e to the negative 2x is equal to 0.25. Again, lots of decimals. Pay attention to them. Now we're going to take the natural log of both sides. This is gone, and we get negative 2x is equal to the natural log of 0.25. And then, of course, divide by negative 2. It's okay if this is a negative answer here, because we don't have the word log in anything, but we don't get a negative answer anyway. We get a small number, 0.6931. For number 25, we're going to divide both sides by 6. Natural log in the problem, so we don't want to take the natural log. And then 24 divided by 6 is 4. To get rid of the log or the natural log, this is swoop. This is how the whole thing started, this quiz, with the no calculator. So swoop this out. E to the 4th is equal to x plus 8. So we're going to have e to the 4th minus 8 is equal to x. Throw that in the calculator, and you get, any time you have e to a power, you get a pretty big number. So this is 46.5982. This last one, they kind of warn you better check your answer, so that's probably something we should do. All have log, right? But we've got kind of a weird algebra problem here. This is a division because of this. This makes a division. So we have x squared minus 2x divided by negative x equals, this is a power, equals x squared. You can multiply both sides by negative x to get rid of this in the bottom. So now we have x squared minus 2x equals negative x to the 3rd. Put everything on one side. So we have x to the 3rd plus x squared minus 2x equals 0. Now we're going to have to factor this. They all have an x in common. And now we have x and then x. Two numbers that multiply give you 2. We want that to be positive, that to be negative. So we get x equals 0. X minus 1 equals 0, so x equals 1. And x plus 2 equals 0, so x equals negative 2. And we better check these. We put the 0 in there. That's right there, I would say. It's not going to work. If we put the 1 right here in the middle, that's going to give you negative. That doesn't work. Now the negative 2, if we put the negative 2 right here where that is a single just x, that's not going to work. So we do get 3 answers, but none of them work, so that's why this one is no solution. So the quiz is a lot shorter than this, but these are the types of problems. Just wanted to give you a lot of extra practice. Good luck on the quiz tomorrow.